Claire Patterson, a brilliant geochemist, embarked on a scientific quest to determine the age of the Earth. His journey was not just a scientific endeavor but a passionate pursuit to unlock the secrets of our planet's past. With meticulous precision, he delved into the mysteries of the Earth's formation, driven by an insatiable curiosity and a relentless dedication to uncovering the truth. Little did he know that his pursuit would uncover a silent killer lurking unseen in our environment. As he meticulously analyzed geological samples, he began to notice something alarming. The presence of lead, a toxic metal, was far more pervasive than anyone had previously imagined. This discovery would set him on a new path, one that would have profound implications for public health and environmental policy. His groundbreaking work, while illuminating the planet's history, also revealed a disturbing truth. Lead contamination was poisoning our world, impacting human health and intelligence on a global scale. Patterson's research showed that lead was not just a localized problem, but a widespread environmental hazard. He found that lead levels in the atmosphere had increased dramatically since the Industrial Revolution, correlating with the rise in the use of leaded gasoline and other industrial processes. Patterson's journey began during the Manhattan Project, the top-secret endeavor to build the atomic bomb. This project brought together some of the greatest scientific minds of the time, working under immense pressure to develop a weapon that would change the course of history. Patterson was among these brilliant scientists, contributing his expertise in geochemistry to the war effort. Tasked with measuring the isotopic composition of uranium, he honed his skills in mass spectrometry, a technique that would later prove crucial in his most significant discovery. Mass spectrometry allowed him to measure the minute quantities of lead in geological samples with unprecedented accuracy. This technique became the cornerstone of his research, enabling him to trace the history of lead contamination and its impact on the environment. Unintentionally, Patterson's work on the Manhattan Project set the stage for his life's work, exposing the dangers of lead and fighting tirelessly to remove it from our environment. He became a vocal advocate for public health, using his scientific findings to push for regulatory changes. His efforts were instrumental in the eventual ban on leaded gasoline, a major victory for environmental health. His legacy is a stark reminder that even the most well-intentioned scientific advancements can have unforeseen and devastating consequences. Patterson's story is a testament to the power of science to uncover hidden truths and drive societal change. His work not only advanced our understanding of the Earth's history, but also highlighted the critical need for vigilance in the face of environmental hazards. Today we continue to grapple with the legacy of industrial pollution, but thanks to pioneers like Claire Patterson, we are better equipped to address these challenges and protect future generations. Patterson's contributions extend beyond his scientific discoveries. He inspired a new generation of scientists and environmentalists to take up the mantle of public health advocacy. His relentless pursuit of truth and justice serves as a guiding light for those who continue to fight for a cleaner, safer world. The impact of his work is felt not just in the scientific community, but in the everyday lives of people around the globe. By reducing lead exposure, we have seen improvements in public health, particularly in children, who are most vulnerable to the toxic effects of lead. Claire Patterson's story is a powerful example of how one person's dedication and perseverance can lead to monumental change. His work reminds us that science is not just about understanding the world, but also about making it a better place. As we face new environmental challenges, we can draw inspiration from Patterson's legacy, knowing that with determination and a commitment to truth, we can overcome even the most daunting obstacles. The unexpected legacy of Claire Patterson is a testament to the enduring impact of scientific inquiry and the importance of advocating for the health and well-being of our planet and its inhabitants. His story is a call to action for all of us to remain vigilant, to question the status quo, and to strive for a future where science and compassion go hand in hand. As we look to the future, let us remember the lessons of the past and continue to build on the foundation laid by pioneers like Claire Patterson. After the war, Patterson turned his attention to a seemingly unrelated question: the age of the Earth. This question had puzzled scientists for centuries, with estimates ranging wildly from a few thousand years to several billion. The quest to determine the Earth's age was not just a matter of academic curiosity, it was a fundamental question that could unlock secrets about the formation of our planet and the solar system itself. Patterson, With his background in geochemistry and his meticulous nature, was uniquely suited to tackle this challenge. Scientists had long sought a reliable method for dating the planet, and Patterson believed that by analyzing the isotopic ratios of lead in meteorites, remnants of the early solar system, he could unlock this mystery. Meteorites, being some of the oldest objects in the solar system, held the key to understanding the age of the Earth. By studying the decay of uranium to lead in these ancient rocks, Patterson hoped to find a precise and accurate measure of the Earth's age. This method, known as radiometric dating, was revolutionary and required an unprecedented level of precision and care. He meticulously worked to eliminate sources of lead contamination in his lab, constructing the world's first ultra-clean room. This was no small feat. Lead contamination was pervasive, found in everything from the air to the very instruments used in the lab. Patterson's dedication to creating a contamination-free environment was a testament to his commitment to scientific accuracy. He understood that even the smallest trace of lead could skew his results, and he went to great lengths to ensure the purity of his samples. This clean room would become a model for future scientific research, setting new standards for laboratory practices. His efforts paid off. In 1953, he announced his groundbreaking finding: the Earth was 4.55 billion years old, a figure that remains the scientific consensus today. This discovery was a monumental achievement, reshaping our understanding of the Earth's history and its place in the cosmos. It provided a timeline for the development of life and the geological processes that shaped our planet. Patterson's work was celebrated in scientific circles and beyond, earning him a place among the great pioneers of modern science. Patterson's achievement was a triumph of scientific ingenuity, but it was during his meticulous research that he stumbled upon a startling and unsettling discovery. As he analyzed his samples, he noticed something peculiar. The lead levels he measured were not just higher than expected, they were alarmingly inconsistent. This anomaly puzzled him, leading him to question the sources of this contamination. What he found would change the course of his career and have profound implications for public health and the environment. The lead levels he measured in his samples were wildly inconsistent, far exceeding what should have been naturally present. This discrepancy suggested that there was an external source of lead contamination, one that was pervasive and widespread. Patterson's curiosity and determination drove him to investigate further. He began to suspect that the source of this contamination was not natural, but man-made. His research led him to the growing use of leaded gasoline, a product that was being widely used in automobiles and industrial processes. This realization set him on a new path, one that would pit him against powerful industries and challenge the very foundations of modern society. Patterson's findings indicated that the widespread use of leaded gasoline was causing a significant increase in environmental lead levels, posing a serious threat to public health. He became an outspoken advocate for the regulation and eventual ban of lead in gasoline, facing fierce opposition from the petroleum industry. His efforts were met with resistance, but Patterson's unwavering commitment to scientific truth and public safety eventually led to significant policy changes. His work not only helped to reduce lead pollution, but also raised awareness about the broader issue of environmental contamination and the need for rigorous scientific research to inform public policy.